collinear forces. Okay. When we discuss about the force, right? The force is a push or pull. This tells about the collinear force. Collinear force means collinear force, L-E, collinear, L-E-N-E-R, collinear, L-E. How to spell collinear force? C-O-double-L-I, C-O-double-L-I-N-E-A-R. Collinear force. Collinear force means having the same line of action. It has the same line of action. When the force is applied on to an object, right? There are three things that we want to study. One, there is a point of application. There is a point of application, the place where we apply the force. And the second one, the line of action that the force will be applied. And the collinear forces means that maybe one or two forces or three forces be applied in the same line of action. In the same line of action. That means one person can be pushed when one person will be pushing, while the other person will be pulling it off. Other person will be pulling it off. One is pushing, the other one is pulling. Then what is the resultant? In that occasion, the resultant will be F1, F2. So the resultant force is F1 and F2. That means you have to add. At the same time, there can be someone pulling it off or push opposite way. Like you have an object. This person is pulling it. This person is pulling it, and the other person is also pulling it to opposite direction. Then we want to find out the resultant of this force, F1, F2. The resultant force will be F1 minus F2. And the direction, the force should have a direction as it is a vector quantity. The direction will be decided by the larger force. For example, if the force here is 20 Newton and this is 15 Newton, the resultant force will be first you put 15 Newton and then I say F2 or F1 F2. I'll put 15 Newton and then 20 Newton. So the resultant will be negative 5 Newton, means the force is applying to the opposite direction. So it is to the opposite direction, right? That is, we talk about the linear forces or the force acting in the same line of action. And the second one is the parallel forces. The parallel forces, right? The parallel forces. if there is an if there is an object, if there is an object, right? There is an object, so you can have the parallel forces. That means two line of actions which are going parallel to each other, which are going parallel to each other, and that two forces are to the same direction. In that occasion, also F1, F2, the resultant force will be F1, F2. F1 and F2, if the parallel force line of actions and the directions are to the same direction, the resultant will be the sum of the two forces. If another force is applied here as a pull, again, that is also, if you extend this one, and that's also going parallel to the third one. So you can add that one also. In the opposite way, if the parallel forces are applied opposite to each other, then some of the two parallel forces will be reduced from the other force which applied to the opposite direction. For example, if you say there's a force, there's an object, there is an object, right? Two forces are applied as 5 Newton and 8 Newton, and another one will be applying the force to opposite direction, and that will be 10 Newton. So what is the resultant of forces that applying on this object? So first you have to say F1, F equal F1 plus F2, F1 plus F2, this is F1, this is F2, and this is F3. And then reduce opposite direction, 1 F3. And you're going to F1, 15, plus 8. Then from that, reduce 10 Newton. The 23 minus 10 will decide 13 Newton. So the direction is to the same direction. If negative mark is there, that's the opposite direction. It's not an opposite direction force. And the third one, the final one you have to study is non-collinear forces. Non-collinear forces. What do you mean by non-collinear forces? There is an object. There is an object, right? So the forces are applied, but they are not acting in the same line of action. They are not acting in the same line of action. They are coplanar, that means acting in the same plane. We are discussing all the coplanar forces, whether it is collinear force, that is applying in the same line of action, parallel forces, non-parallel forces. So we call them coplanar, that means applying in the same line of action. And what is the resultant of these two forces, F1, F2, F2? So the resultant is not F1 plus F2. No, not F1 plus F2. It has to be calculated, and it is not in your syllabus. So you don't want to find out the resultant of these two forces, and only the things that we want to know that all the line, when you extend the line of actions, that line of actions meet in one place, and the direction is decided by the F1 and F2 forces. So you can find out the magnitude. I'll just show you how it can be done, but not in your syllabus. how to get the magnitude and the direction. It is done something like here. There is an object. Are you there, Wolf? Only I'm speaking now.
No, yes, we are here.
Ah, you are here. I do. Thank you. I'm sorry. My late today. That is for the first time occurred in my class history, right? So you are applying, imagine that 30 Newton, and you are going to apply here, apply here. New update is good in one way, that the straight line can be drawn, not like the old version, but there are some ones after the update. If you say this is 10 Newton, the resultant is not 30 plus 10, 40 Newton. No, it is not 40 Newton. It is wrong. Then what you can do is, that you have learned in lower grade classes that the force can be represented by the diagram which is drawn to a scale. I mean, if you say 30 Newton, and then you can extend this one, you can extend the line of action and extend this line of action as well. So then you can have the angle here and draw the diagram according to the scale. 30 Newton, if you say 5 Newton is represented by 1 centimeter, right? 1 centimeter equal 5 Newton. Then you have to draw a line with how many centimeters? 6 centimeters, if I'm correct. Draw 6 centimeter line and get the angle here. Then how many centimeter one should I draw here? You did not get what I said? Aditya?
2 centimeters.
2 centimeters. Yeah. You draw 2 centimeter line. Now, what you are going to do is complete. Draw the parallel line. Draw the parallel line. Right? Parallel line. And then complete this one as well. And now you have the line drawn from this corner to the other corner, right? And measure the length of the line from here. What is this? In English, in maths, what is this one you call? What is it?
Diagonal.
What is it?
Diagonal.
Diagonal. Right. And measure that one. If you have, this is 2, and if you have this one as 8 centimeter, 8 centimeter, imagine. Not 8, it should be like 7 centimeter. All right. So then what is the resultant force then? 7 multiplied by 5, 35 Newton. Am I correct? Because you have to convert that centimeters back into the force. So the resultant of these two forces will be 35 Newton, and the direction is indicated from this line. But that is not included in your syllabus, so no worries. I just showed you how it can be done, but you don't want to study that one. Only the things that you have to know when the forces are non-collinear. You have
Is
to.
in grade 11 syllabus?
No. There is in your maths A level. Only A level you have, not in O level syllabus. What you have to know is resultant of two inclined forces. Two inclined forces. It says two forces P and Q act in the same line action. Shown when two such forces are applied an object, the object does not move in either the direction P or Q. In such instance, the direction of motion of the object lies in a direction between the two forces. That's all. Yeah. Okay. So we can have some questions. Any clarifications from this to tell you the summary of the force? Summary of this one? Summary of this one? You want to know this one? One. You should know that force is push or pull. Force is a push or pull. Unit of force is Newton. And a force has these things are there. A force has one. A force has point of application. Point of application. Point of application. Second, line of action. Line of action. Point of application. Line of action. Then direction. Next, force can be represented. Force can be represented. Represent, Presented, represented by one. Point of application. Point of application. A dot. A dot. Direction. An arrowhead. An arrowhead. Magnitude. Magnitude. A line drawn to a scale. A line drawn to a scale. පරිමාණයට අඳින ලද රේඛාව සරල රේඛාව drawn to a scale. උදාහරණයක් example you can draw like this. So this is the object, and you can have point of application. This is the point of application, the direction, magnitude, 5 Newton, or rather 6 Newton. So then you draw a 3 centimeter line as 1 centimeter equals, yeah, as 2 Newton, sorry, as what? 1 cm equal 2 Newton, 2 Newton equal 1 centimeter. And this is the line of action. So you can say line of action, not in your syllabus. This is all that you learn this one in lower grade class, like grade 8, 9 magnitude, right? And the other one, sorry.
So can you move this page upward a little bit?
Yeah, sure. 1 second. Can you see now?
Okay, sir. Thank you, sir.
Right. Now, yeah, force can be represented by point of application. You know, not like the old whiteboard version. The latest one is giving me a little trouble when writing. Smoothly can't write. Then there are certain other things relevant to the force you have to study. The Newton's law of motion, F equal ma, like the force is related with the mass and the acceleration. There are some other applications. I'm not going to discuss that under this lesson. Then this lesson you have to study about this one. What is it? That is under this lesson you have to study. මේ අපරාධ මේ බලන්න මේ බෝඩ් එකේ මෙච්චර ප්‍රමාණයක් කිසි තේරුමක් නැතුව නාස්ති කරලා. නාස්ති කරලා ඒ කිසි තේරුමක් නැහැ ඒ ඒක අප්ඩේට් එකකින් ආපු ෆෝල්ට් එකක්. ඉතින් මෙච්චර ලොකු ස්ක්‍රීන් එකක් අරගෙන මෙච්චර ප්‍රමාණයක් නිකන් නාස්ති කරලා දාපුවාම ලියන්න ඕනේ ලොකු ලියුමක් මයික්‍රොසොෆ්ට් එකට නේද? තේරුම් ගන්න එක අපර වටිනාම දේ මේ මෙහෙන් හංගලා දැම්මා නම් ඉවරයි. So I won't write that. මේ පාඩමේදී අපිට ඉගෙන ගන්න ඕන resultant of resultant, RESULTANT, resultant of forces. Occasion 1. Occasion 1. Occasion 1. Forces applied on the same line of action within bracket collinear forces. Collinear forces, COLLINEAR, collinear forces. That can be calculated. That can be calculated in this way. One, if forces are applied to same direction same direction. If the forces are applied to the same direction, like this, the force is there, F1 and F2, then the resultant will be, the resultant one, F will be F1 plus F2. Example, the force is there, you put 5 Newton and then another 10 Newton. So the resultant will be 5 plus 10, 15 Newton. 15 Newton. Then forces are applied to the same direction. Second one, if the forces are applied opposite direction, when the forces are applied in opposite direction, let's see how it happens. When they are applied on opposite direction, right, one force is applied there, and in the same line of action, the other force is applied to opposite direction. So this is F1 and this is F2. Right, now you have two occasions. What are the two occasions? One, F1 is larger than F2. F1 is larger than F2, right? Example, F1 is 15 Newton, F2 is 10 Newton. F2 is 10 Newton. F is positive value. Positive means applied to particular direction. Particular direction. Applied to particular direction. Example, in this occasion, the object is there. So this one is 15 Newton and oppositely applied 10 Newton. So the resultant will be 15 minus 10. So 5 Newton to the same direction. It's applied to the same direction. F1 is bigger and F2 is smaller. So if you go to the other one, if you go to second one, F1 is lesser than F2. Example, F1 is 5 Newton, F2 is 15 Newton. And then now let's see what happened. F then is resultant force is negative. Negative. That means force is opposite. force is applied, force is applied to opposite direction. Force is applied to opposite direction. Force is applied to opposite direction. I think you can see now clearly. Can you?
Yes, sir.
Right. Now, example. This is the object, and to the particular direction, 5 Newton, and opposite direction in the same line of action, 15 Newton. 15 Newton. So what is the resultant? Let's say F equal F1. Actually, the resultant force, පොඩි වරදක් කරා මට තප්පරයක් දෙන්න. මෙන්න මෙහි නෙගටිව් ලකුණක් දැම්ම නේද? මේක නෙගටිව් නෙමෙයි. මෙන්න මේ ලියපු එක මෙතන ලියන්න ඕන මෙන්න මෙහිමයි. මෙතන මම චුට්ටක් හදනවා එතන. resultant force එකක් නේ එකතුවක් එන්න ඕන. එතකොට F1 plus F2 එම එන්න ඕන. හැබැයි මෙතන පොඩි ප්‍රශ්නයක් තියෙනවා. මොකද්ද? එතකොට F equal F1 is 15 Newton. No problem. Plus 10 Newton තියෙනවනේ. අන්න ඒක negative 10 Newton. අන්න එහෙමයි ලියන්න ඕන අපි. මෙන්න මෙහෙමයි ලියන්න ඕන. Resultant force එකක් නේ. So you have to add that. එතකොට මෙතන මම මෙතන ලියන්නේ කොහොමද? F1 මෙතන ලියන්නේ අපි F1 plus F2. F1 plus F2. F1 5 Newton plus F2 කියලා කියන්නේ minus 15 or negative 15 Newton. Negative, not minus. Negative 15 Newton. Opposite ne. Then අපි ලියනවා එහෙනම් 5 Newton negative 15 Newton. Result එක මොකද්ද? Negative 10 Newton. ඒ කියන්නේ අපිට ලියන්න පුළුවන් ඕනනම් මොකක්ද? The resultant force is 10 Newton. හැබැයි direction එක opposite. නමුත් උත්තරේ අපි ලියන්නේ මෙන්න මේක. Applied opposite direction. Applied to opposite direction. Collinear forces can apply in the same line of action. අපි ලියාගෙන ගියා note එක කොහොමද ඉන්න පෙන්නන්නේ. ලියා හිටපු එක සම්පූර්ණ note එක ඔන්නෝම එනවා. ඔව් මේක ගැනයි අපි ඉගෙන ගත්තේ අද. ඔන්නෝම පරක් වෙලා ආපු අයට ගන්න පුළුවන් screenshots. මේ විදිහට හරිනේ. ඊට පස්සේ ඊළඟ කොටස ඊළඟ කොටස වෙන එකක් වාගන්නවා. මේක application එක සම්පූර්ණ එකෙන් සෙන්ටිමීටර් 6ක් සම්පූර්ණයෙන්ම අපිට අහිමි කරලා Microsoft එක. කිසි බේරුමක් නැතුව. Yeah. So then I just went on writing what? The resultant of forces, occasion 1, forces applied on the same line of action. And now I am moving to occasion 2. Occasion 2. Occasion 2. Occasion 2 එකේදී මොනවද මම කියන්න යන්නේ? The forces applied parallelly. Parallel forces. P-A-R-A-L-L-E-S. Parallel forces applied. Parallel forces applied on two line of action. Two line of action. Applied two line of actions. අපි බලමු applied two line of actions. Then resultant force. Resultant force equals F1 plus F2. Product. Resultant force equals same direction. Same direction. Same direction. ලස්සනට ලියවෙන්නේ නැහැ. ඒ කියන්නේ there is an object. One force is applied 10 Newton. Another force is applied 5 Newton. So the resultant force is F equals F1 plus F2. Now 10 Newton plus 5 Newton. The resultant is 15 Newton to the same direction. Parallel forces applied in two line of action, resultant, same direction. And we'll go to the opposite direction. Second, opposite direction. Opposite direction. Opposite direction. කොහොමද opposite direction එක බලපාන්නේ? ඒක එන්නේ මෙහෙමයි. Opposite direction. They are parallel. The forces are there. One is applied like 10 Newton, and the other one will be applied opposite direction. Okay, or you can draw here as well. 10 Newton, opposite direction. Make it better. 5 Newton. අපි දන්නවා resultant එක F equal F1 plus F2. ඒ කියන්නේ මෙයා ලිව්වා මේ පැත්තට 10 Newton plus then 5 Newton opposite නේ within bracket negative 5 Newton. අතන මොකද එන්න ඕනේ? 10 Newton negative 5 Newton. So 5 Newton to the particular direction. So make a ප්‍රතිඵලය තමයි 5 Newton to the same direction. Right. අනිත් එක තුන්වෙනි අවස්ථාවට අපි යනවා a non-collinear forces. Non collinear forces. Non-collinear forces. May second occasion main occasion 3. Occasion 3. Non-collinear forces. Non-collinear forces. Non-collinear forces. ඒ කියන්නේ inclined forces. Inclined forces. The resultant of inclined forces. Right. Resultant is RESULTANT. Resultant is not the sum of two forces. Sum of two forces. Direction will be in between the two forces. In between the two forces. In between the two forces. Example. There is an object and one force is applying to this direction. The other force is applying to this direction. So, if this is F1, if this is F2, resultant is F equal F1 plus F2 Q-watt. Varadi. That's not correct. Okay. And the direction will be somewhere here in the middle. We don't know the exact direction, what it is. That's all what we have to study in this unit. And going to have some questions. Is it okay?
Yes, sir.
Anything
Okay.
you want to know about this? No problem. Grade 11th, sometimes you will not get the questions from this one, sometimes maybe, we don't know. If you want to take the summary of this one, too small. අපරාධ මේ ස්ක්‍රීන් එක මට දෙන්නේ නැහැ ඉතින්. මේක එහෙම දාලා නේද? Microsoft Office එක. පේනවද වල චුට් වැඩිද? පුතේ ඔයාලා හිතන දේ මට ඇහෙන්නේ නැහැ. කතා කරලා කිව්වොත් විතරයි මට. Parallel forces opposite වෙනවද? Parallel forces opposite වෙනවද? Two parallel forces? Right? Then parallel forces opposite වෙනවද කියලා අහනවා. මම මේක විචාර කරනවා. මේක කියන්න මට මෙහෙම තිබ්බහම මේ force එක ගත්තොත් මේ force එක මේ object එක ගත්තොත් නෑ අනිත් පැත්තට මේක බලන්න. මේ ඔබ්ජෙක්ට් එක. හරි. මම මෙහෙම ෆෝස් එකක් ඇප්ලයි කරනවා. මෙහෙම ෆෝස් එකක් ඇප්ලයි මෙහෙම ෆෝස් එකකුත් ඇප්ලයි කරනවා. හරි. මේක මෙයා අපි හිතන්නකෝ 20 නිව්ටන් කියලා. මෙයා 10 නිව්ටන්. මට කියන්න resultant force එක කීයද?
So 10 Newton का direction है हमका.
ඈ
10 Newton का
न्यूटन
direction.
का डायरेक्शन है और
කීයද මේකේ resultant එක?
सर डायरेक्शन है क्या
අපිට ඉෂුව එකක් තියෙනවා. මොකද්ද ඉෂුව එක? උත්තරේ කියන්න බෑ අපිට. ඇයි? මෙන්න මෙයාගේ ඩිරෙක්ෂන් එකක් දීලා නැහැ. ඔයා මම මෙහෙම ඩිරෙක්ෂන් එක දැම්මා නම් උත්තරේ කීයද?
30
30 Newton.
මම ඩිරෙක්ෂන් එක මෙහෙම දැම්මා නම්
10
10 Newton.
ඔව්. ඒ කියන්නේ එක එහාට දානවා මෙහාට දානවා නේ. හැබැයි මේ දෙන්න parallel. මේ parallel නැද්ද? Two line of actions නේ. Two line of actions නේ. එහෙම නේද? ඔව්.
yes
මේක මේ වගේ එකක් ඔයාලට එන්නේ නැති වෙයි. හේතුව මේකේ අවසාන රිසල්ට් එක තියෙන්නේ couple of forces නේද? මෙහෙම එකක් නේ නිකන්. දැන් මෙයාගේ මෙහාට 20 නිව්ටන් දානවා මෙහාට opposite එකට 10 නිව්ටන් දානවා. එහෙම නේද? couple of force වගේ එකක් මට පේනවා. නිසා don't worry about this matter. හරි අපි ප්‍රශ්න දෙකකට යන්නද?
okay
Okay, sir.
Yes. The time is 5:26. ප්‍රශ්න දෙකකට යන්න. මේක ලියනවට වඩා මට මෙන්න මේක ලියනම හොඳයි. මෙයා මට කචා. One second. ඒ board එකේ ලියන්න බෑ අපරාධي. I have to find out another application. Microsoft la bamboo. Software තිබුණා. එක මාධ්‍ය
මොදලාදී
අප්ඩේට් කරලානේ. දැන් මේ ඒ කියන්නේ Microsoft මම යූස් කරන්නේ ඒගොල්ලන්ගේ white board එක. ඒගොල්ලෝ මේක අප්ඩේට් කරා. ඔතන හරි කරදරයක් හැමතිස්සෙම අප්ඩේට් කියනවා මගේ අතින් ලැබුණා. දැන් අප්ඩේට් එකේ රිසල්ට් එක මේ ඔයාලට පේනවනේ මේ තීරුවක් මේක මම මේ ස්ක්‍රීන් එකේ මේ ටික මට යූස් කරන්න බෑ. එතකොට මේකට මම මුදල් කෙරුවොත් එහෙම ඒක නාස්ති වෙන මගේ කාලේ මෙතන මට ලියන්න පුළුවන්. මේ ටික ලියන්න බෑ. අපරාධයක්. ඊගාවට මෙතන මෙන්න මේක ඔබලා. මේ තියෙන්නේ මගේ හොඳම තැනනේ. මම ලියන්න දෙන හොඳම තැන. මේකක් ඔබලා. ඒක මෙතනට දැම්මම මට left hand එකෙන් මේක මාරු කරන්න පුළුවන්. දැන් ලියනකොට රතු පාටින් කොළ පාටින් ලියාගෙන යන්න ඕන නම් මම මේක ටක් ගාලා මෙතන ප්‍රෙස් කරනවා. කොළ පාට එනවා. ආයේ
සෑයක මූව් කරන්න බැරිද
බෑ මූව් කරන්න බෑ. ඊළඟට මේ දීලා තියෙන මට ඔප්ෂන්ස් දෙකයි. අනිත් එක තමයි මේකේ cut and paste කරන්න. මම අරගෙන තියෙන එකක් ටක් ගාලා මෙතනට ගෙනලා දැම්මා. PDF එක මම මේකට අප්ලෝඩ් කරා. මොකක්වත් බෑ. අප්ග්‍රේඩ් එකේදී අර පරණ එකේ තිබුණු ෆැසිලිටි එකෙන් 10න් එකයි මේක තියෙන්නේ 90ම cut off අට fail
කම්ප්ලේන් නැද්ද මං හරි
ඔව් කම්ප්ලේන්ට් කියන්නේ ඉතින් මම දැක්කා මේවා ගොඩාක් දාලා තියෙනවා මේ මොනවාද රිවිව්ස් දාලා තියෙනවා ඉතින් අයි දන්නේ හැම කරේ කියන එක එයාලගේ පරමාර්ථය මොකක්ද දන්නේ එකක් ඉතින් Zoom එකත් එහෙමනේ Zoom එකේ ඒගොල්ලෝ දන්නේ නැහැ අපි ඇප්ලයි කරන්නේ මොකටද මේක කියලා. එයාලා බලන්න එයාලගේ ඇප්ලිකේෂන් එකක් මේ පල්ලි වල යාඥා කරන්න ඒ වගේ අර මීටින් අපි මේවා ගන්න ක්ලාස් කරන්න. එතකොට අපේ අවශ්‍යතාවය නේද? ඉලීගල් පාටිසිපන්ට්ස්ලා එනවාද? නැත්නම් Zoom platform එක උඩ වැඩි ගොඩාක් අපිට ගැලපෙන ආකාරයට හදාගන්න පුළුවන්. දැන් උදාහරණයක් විදිහට මේ ක්ලාස් එකට එන ඔයාලගේ අනන්‍යතාවය ගැන අපිට අපේ දෙන අනන්‍යතාවය ඔයාලා චෙක් කරගන්න ක්‍රමයක් නැහැනේ. ඒගොල්ලන්ට හදන්න තිබුණානේ. මේ එන්නේ හවල්. එතකොට third party application එකක් අපිට දාන්න ඕනේ වෙන්නේ නැහැ. දැන් අපි දාගෙන ළඟලනෝනේ third party app එක. මේ කවුද අපි දුන්න අපේ රෙජිස්ටර් එකේදීද මේගොල්ලෝ එන්නේ? All right. This is smooth. You can see this, right?
yes sir yes
Clear. Resultant force. Resultant, R-E-S-U-L-T-A-N-T. Resultant force. Question. Questions. Find out the resultant resultant of the force in the following occasion. Roman number 1. Newton, 5 Newton. 10 Newton, 5 Newton. 2. 20 Newton. 10 Newton. 3. 20 Newton. 20 Newton. Second one. Second one. A set of students. A set of students arranged an experiment and the setup of the experiment is given below. Setup of experiment is given below. A, B, C. Question number 1. Question number 1. What are A, B, and C? 2. What is the unit marked on A, B, and C? Third one. If the forces of um, 10 units on B and 12 units on C are applied, write the observation on A. Write the observation on A. Fourth one. What is the conclusion of the experiment? What is the conclusion of the experiment? 5. Give an example occasion in our day-to-day life for the above occasion. For the above occasion. Third question. Third question. Find out the resultant of forces in the following occasion. 1. A man is running with a constant velocity. 2. A box of 10 kilogram is kept on the floor. The box of 10 kilogram is kept on the floor. Third, at a game of tug of war, 10 people joined, J-O-I-N-E-D, joined as 5 equal number of people were divided, D-I-V-I-D-E-D, divided to either side, E-A-E-A-C-H. Each person applied 50 Newton, except one person on left side applied 2 Newton greater than his usual force. Find the resultant, R-E-S-U-L-T-A-N-T, resultant force. ඇති නේද? Enough?
Okay, sir.
Right. Work it out. Finish your answering. All right. Can we discuss the answers?
Done.
Can. Everybody?
Okay, sir.
Okay. Here you can see the one. Should I share the screen or can I use the same way? මෙහෙම තියන්නනේ. Resultant force. Find the resultant of the forces in the following occasion. Right. What is the resultant force of this occasion? 5 Newton, 10 Newton. F equal F1 plus F2 ඒ කියන්නේ 5 Newton plus 10 Newton equal 15 Newton. Direction එක positive same. මෙයා F equal මේ දෙක F equal F1 plus F2. F1 10 Newton. Then මෙතනදී particular direction F1 එක 20 Newton. Right. 1 second. F1 මෙයා F1 නම් negative 20 Newton plus 10 Newton. Result එක negative 10 Newton. ඒ කියන්නේ opposite direction. Third one, F equal F1 plus F2. F1 20 Newton. F2 20 Newton. So it's 40 Newton. Clear? Good?
Yes, sir.
And move into the other one. A set of students arranged an experiments and the setup of the experiment is given below. Right, A, B, C there. What are A, B, and C? Unexpected answers. What are A, B, and C? What are A, B, and C?
Spin balances. Newton spin balances.
Yeah, they are Newton balances. You can say spin Newton balances. Newton balances. Second, what is the unit marked on A, B, and C? The answer? කියන උත්තරේ.
Newtons.
Are you sure?
Capital N.
Huh?
Capital N.
Are you sure?
Yes.
කිලෝග්‍රෑම් නෙමෙයිද? කිලෝග්‍රෑම් නෙමෙයිද?
අනේ sir.
No, sir.
Now නිව්ටන් බැලන්ස් කියලා තියෙද්දි ආයේ කිලෝග්‍රෑම් වෙනවද කොල්ලනේ? නිව්ටන්. නිව්ටන් බැලන්ස් කියලා තියෙනකොට ආයේ කිලෝග්‍රෑම් කියලා කියනවද ඒකේ? නෑ. ඒ වගේ පොඩි සැකයක් තියෙනවා ඩවුට්ස් නේද? Third. If the forces of 10 units දැන් පරිස්සම් වෙනවා නිව්ටන් කියලා කියන්නේ නැතුව ඉන්න නේද? මොකද එහෙම ප්‍රශ්නයක් ඇහුවා නේද? If forces of 10 units on B then B මත දානවා හරි B equal 10 units කියලා කියන්නේ Newton and 12 newtons on C මත දානවා 12 Newton දැන් අපි units කීකද යන්න ඕනේ නැහැ and applied right observation on A එහෙනම් A ගේ කොච්චරද force එක මේ දෙන්නගේ එකතු වෙන්න ඕනේ මෙතනනේ කීයද A equal B plus C B කියන්නේ 10 newton C කියන්නේ 12 newton උත්තරය 22 newton එතන මොකද්ද observation එක the reading of A is 22 newton the reading of A is 22 newton what is the conclusion of the experiment what is the conclusion of this experiment the resultant of the two parallel force is equal to sum of them the resultant of two parallel forces given ප්‍රශ්නේද what is the conclusion fourth the resultant resultant the resultant of two parallel forces applied to same direction to the same direction is the sum of the two forces the sum of the two forces give an example occasion in our day-to-day life for the above occasion මොකද උදාහරණයක් අපි two people are pulling a cart. Two people are pulling a cart. කරත්තයක් මිනිස්සු දෙන්නෙක් ඇදගෙන යනවා. කරත්තේ දානවා බෝල්ලිය තියෙන බෝල්ලි දෙකක් තියෙනවා. එක ලීයකින් අදිනවා අනිත් එක අනිත් ලීයෙන් අදිනවා. හරි. Can I go to the other one?
Yes, sir.
Find out the resultant of forces in the following occasion. find out the resultant of forces in the following occasion. Number one, a man is running with a constant velocity. මට කියන්ට ඒකේ resultant force එක කීයද කියලා?
0 newtons.
0 Newton. Constant velocity එකකින් යනකොට ඒකේ resultant force එක 0. Until an unbalanced force is applied. එහෙමයි කියන්නේ. Until an unbalanced force is applied. The object which is moving with the constant velocity tend to move with the same velocity. A force at a stationary force remains stationary. Unbalanced force is a balanced force කියලා කියන්නේ 0. And 2. What is it? A box of 10 kilogram is kept on the floor.
100 newtons.
කීයද?
0 newton.
100 Newton ද 0 Newton ද?
0 newtons.
Oh yes. Good effort boys. මෙන්න object එකක් කියලා තියෙනවා. මෙයාගේ 10 kilogram. Sorry, 10 kilogram. 10 kilogram කියලා කියන්නේ F equal W equal mg. M කියන්නේ 10යි, G කියන්නේ 10යි. 10 කියන්නේ 10 to the 10 meters per square second. Gravitational acceleration. එහෙනම් මෙතන 100 Newton. 100 Newton. අර මම ඉස්සෙල්ලා කිව්වා වගේ Newton's first law of motion. Until an unbalanced force is applied on, the stationary object remains stationary. ඇයි මෙයා පහළට 100 Newton apply කරනවා. හැබැයි flow එක ඊට සමාන force එකක් R, normal reactive force, upward apply කරනවා. ඒක සමානයි 100 Newton වලට. එහෙම නොවුනා නම්, if that is not there, just like Devadatta, this one will be sinking in the ground because the downward force is greater and no upward force. So this one will be moving down with the right and acceleration. Or if the upward force is greater, this will be flying up, right? But this is nothing happens. This is an occasion where nothing happens. So it means that the forces, the resultant of the forces applied on that particular object is 0. And last one. Sorry about you lost 30 minutes today because of my fault. Actually, the machine. At a game of tug of war. Tug of war කියන්නේ කඹෑදීමනේ. 10 people joined as equal number of people joined as equal number of people were divided to either side. 10 people equally divided into either sides, right? So you have the tug of war, a rope is there, and mark 5 people pulling this way, 5 people are pulling this way, and the other people are to other direction. Other 5 people are, they are 1, 2, 3, 4, and 5. Right? So they are pulling. Each person applied 50 Newton. හැම එක්කෙනෙක්ම 50 Newton ගානේ දානවා except one person left side. මේ side එකේ. මේ පැත්තේ left side එකේ. මේ පැත්තේ ඉන්න එක්කෙනෙක් 2 Newton වැඩිපුර දානවා. Force. Find the resultant of force. And resultant එක කීයද?
2 newton.
2 Newton towards left side.
2 Newton to left side. My dear, you have to mention the direction because all together. You don't want to calculate all. මෙතන එහෙනම් එකෙනෙක් කීයද දානවා කිව්වේ? 50 Newton. එතකොට 50 වැඩි කිරීම 5 නේද? 250 Newton මේ පැත්තට 50 වැඩි කිරීම 5 252 Newton මේ පැත්තට. මොකද එකනේ දෙකක් දානවනේ. ඒතර පසර පස්සේ 250යි 2යි 252යි. එහෙනම් resultant force එක මොකද්ද? මෙහාට resultant force එක resultant force can be something like this, right? F equal F1 plus F2. Now F1, this one, 252 negative Newton plus 250 Newton. So that way, so the resultant is negative 2 Newton. That means you can say negative 2 Newton, or else you can write 2 Newton to its left side. Hope you enjoyed my lesson. Did you?
Yes, sir.
Was it a successful effort?
Yes, sir.
Yeah. Let's see. And we will be meeting on Wednesday. Bye then.
Thank you, sir.
Bye. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Goodbye.